Good morning, everybody. This is Miss Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Deshpande Institute of Technology, Halia. In the previous class, we were discussing about what you mean by Fourier transforms, why Fourier transforms are required, and how is it defined, how to find the Fourier transform of certain real valued functions. All these things we have discussed. In Fourier series that we have discussed in the previous module, that is Fourier series, we express a real valued function in terms of series of terms. Correct? We express them as series of terms. But here in Fourier transforms, we express a real valued function in terms of the integrand, where it is defined as Fourier transform is defined capital f of x is equal to integral minus infinity to plus infinity f of x e power I ux dx. Because of this infinite term, Fourier transform can also be regarded as infinite Fourier transform. This Fourier transform can also be regarded as infinite Fourier transform. And because of this e power iux term, it contains an iota term. That's why it can also be regarded as complex Fourier transform. Complex Fourier transform. These all three mean the same thing. Correct? So this is how a Fourier transform is defined as. And Fourier transform, it is an important image processing tool which is used to decompose an image into sine and cosine components. This is what the Fourier transform does, or Fourier transform, Fourier analysis is done. And there is a concept called Fourier transform. It's a mathematical method for transforming a function of time into function of frequency. Okay, it can be used to convert or transform a function of time into a function of frequency, and sometimes it's described as transforming from time domain to frequency domain. And it is usually useful for the analysis of time dependent phenomena. It may be useful when you discuss about waves and how to transform one particular wave to other terms. Here we are mainly dealing with sine cosine, converting a particular function to sine and cosine transforms. That is what we are discussing about. Next, we have discussed also about inverse Fourier transform. How inverse Fourier transform is defined, that also we have discussed. So inverse Fourier transform is defined by, again it is defined by the integral f of x is equal to 1 by 2 pi integral minus infinity to plus infinity f of u into e power minus iux du. Remember this. In Fourier transform it is dx, in Fourier inverse transform it is du. Remember this, these formulas are important. Then we have discussed, I have given briefly certain properties. Then also we have discussed about Fourier sine and Fourier cosine transforms. Formulas also I had given, and we have discussed 2 questions based on that. So let's discuss few more questions in today's class. Okay. Next question. Find the Fourier transform of, the next question, we have discussed 2 questions already. This is the third one. Find the Fourier transform of f of x is equal to e power minus mod x. So here they have asked us only to find the Fourier transform. So Fourier transform is given by f of u is equal to integral minus infinity to plus infinity f of x e power iux dx. This is the formula of Fourier transform. Then what we have to do, we have to substitute for f of x. What is f of x? F of x is given to be e power minus mod x. So how f of x is defined as? Just remember, said mod x. The x value may be either positive or negative. Mod x. Mod will give you always positive value. But here x will have 2 different choices. It may be either positive or negative. Modulus of a value will give you positive, but that inside the modulus this x may be positive or negative. So depending on that, f of x is minus mod x, which is defined as e power minus x for x less than or equal to 0. Suppose if x is less than 0, mod x value here x will be minus. And for x greater than or greater than 0, minute. Here you have negative sign, correct? Power minus x. Here over here you have negative term over here, correct? It's minus mod x. Suppose if you have all the values of x which are greater than or equal to 0, that means x values are all positive for all values of x greater than or equal to 0. Remember this, mod value will give you always mod x will be plus x if x is greater than 0, and mod x is minus x if x is less than 0. So for all the values of x greater than or equal to 0, mod this x will be positive because it is x is greater than or equal to 0. X is greater than or equal to 0 means mod x value will be plus x itself. But here we have e power minus, so you will have e power minus x. Now when you take x is less than 0, x is negative. That means this x is negative for all the values of x. We are talking about only the values of x. It will be negative. So e power minus of minus will become e power plus x. This is what is the meaning. This is how it is defined. But always remember this, how mod x is defined. Mod x is defined to be, always remember, it is positive for all the values of x greater than or equal to 0, and it is negative for the values of x less than 0. But modulus of any number is always positive, but it is defined this way. For all the values of x greater than or equal to 0, mod x is plus x, and for x less than 0, mod x will give you the negative of it. So f of x is given to be e power minus mod x. That's why we will take it as e power minus x for x greater than or equal to 0, and e power minus of minus x, which is e power plus x for x less than 0. Now you can split this integrand into minus infinity to, I will split into two parts, that is minus infinity to 0. Minus infinity to 0 means for all the values of x less than 0. Minus infinity to 0 means it will have all those values which are less than 0. For that, f of x is defined to be e power x. So e power x, e power I u x dx. So second part will be 0 to plus infinity. I have split integral minus infinity to plus infinity in two parts, minus infinity to 0 plus 0 to infinity. I have split into two parts. So according to this, whatever we have got, we have written. Now suppose if x lies between 0 to infinity, that is for all the values of x greater than or equal to 0, function value is what? E power minus x. So f of x is e power minus x, e power I u x dx. I hope this is clear. Anybody has in this, please ask. Okay, next, suppose integral minus infinity to 0. Now you can combine this e power x plus iu x. So if you can take x outside, it will become 1 plus iu into x dx. Similarly over here, 0 to infinity, e power, if I take minus and outside, it will be x plus, is it x plus? It will be x minus, or you can take minus x outside. If I take minus x outside, what will remain? 1 minus iu into x dx. From this term, e power minus x into e power iu x. That will be e power minus x plus iu x. That is equal to e power minus x. If I take outside, 1 minus iu remains. That's what I have written over here. Now let's continue this. What do we get? We have to integrate this term with respect to x. So when we integrate, e power x is e power ax. Integration of e power ax is e power ax divided by a. So according to that, here it will be 1 plus iu x divided by 1 plus iu. Limits vary from minus infinity to 0. Next, integrate the second part. What do we get? Similar concept, e power ax is integration of e power ax is e power ax by x. So we will have over here e power minus 1 minus iux divided by minus of 1 minus iu. Limits vary from 0 to infinity. So let's substitute the limits. What happens when we substitute the limits? Let's put the upper limit as 0. So e power 0 it will become, I will take 1 plus iu. 1 plus iu e power 0. E power 0 is 1. Next e power infinity. Correct? What do we get then? E power infinity, e power minus infinity it will be. Here you will have the term e power some term into minus, x is minus infinity. So it is similar to e power infinity, which is infinity. When this term approaches to infinity, the entire term will approach to 0 because 1 by infinity is 0. Okay, e power minus infinity we get, that is 1 by e power infinity, and 1 by e power infinity will be 1 by infinity, which is equal to 0. So when we put the lower term, it will become 0. Now let's substitute for this term. So we have here plus, when you put here same again, here the upper limit is infinity. So when you put upper limit as infinity, it's 1 by e power infinity, which is 1 by infinity and which is equal to 0. So we will have the upper limit as 0 minus, here you have minus 1 minus iu into lower limit that is, what is the lower limit? 0. So when you put 0 over here, e power 0, which will be 1. This is what we get. So we will have 1 plus iu, minus of minus will become plus 1 minus iu. When you take the LCM, it's a plus b into a minus b. A plus b into a minus b is a square minus b square. b is iu. So a square minus b square, when we take the LCM, what happens? 1 minus iu plus 1 plus iu. So here minus iu plus iu get cancelled. So we will have over here 2 times 1. See here, I square u square. I square is minus 1. Minus into minus will become plus. So we get 1 plus u square. So this is the Fourier transform of the function f of x is equal to e power minus mod x. Anybody has any doubt in this question? Please answer. Anybody, any doubt?
No, ma'am.
Okay, let's discuss the next question. Find the Fourier transform of f of x is equal to 1 minus mod x for mod x less than or equal to 1, 0 for mod x greater than 1. Okay, so this is the next question and we need to deduce that 0 to infinity sin square t divided by t square into dt, that is equal to pi by 2. So we need to find the Fourier transform of this and then we deduce that to this expression. So let's find the Fourier transform of the given function. Formula is given by f of x is equal to integral minus infinity to plus infinity f of x e power I ux dx. So that is equal to, see here, where does the limits vary from? Check, tell me. I have discussed a similar question in the previous class. See here we have 2 terms over here. For mod x less than or equal to 1, function is defined to be 1 minus mod x, and for mod x greater than 1, function is defined to be 0. So what do you mean by mod x less than or equal to 1? I have discussed this in the previous class as well. Mod x less than or equal to 1 means x lies between plus 1 and minus 1. This is the meaning of mod x less than or equal to 1. X lies between plus 1 and minus 1. So when x lies between plus 1 and minus 1, this integrand now converted to minus 1 to plus 1 because it is defined 1 minus 1 mod x as for all the values of mod x less than or equal to 1. For mod x greater than 1, it is 0. So we need to consider the limits minus 1 to plus 1. F of x is 1 minus mod into e power I ux dx. So this is what we get. Anybody has any doubt in this? Anybody any doubt in this step?
No, ma'am.
Okay, let's continue then. So what do we have over here? F of that is equal Now see this minus 1 to plus 1, I can split into two parts, that is minus 1 to 0. Okay, because here mod x is there, mod x is there, and we know that mod x will be, when is it positive, mod x will be plus x for all the values of x greater than or equal to 0 and minus x for all the values of x less than 0. Okay, this is the definition of mod x. Mod x is plus x for all the values of x greater than or equal to 0 and minus x for all the values of x less than 0. So when I split this minus 1 to plus 1 in two parts, that is first one is minus 1 to 0, second one is 0 to plus 1. Minus 1 to plus 1 I have split into two parts. So first case, when it is minus 1 to 0. Minus 1 to 0 means we will have all the values which are less than or equal to 0. So when x is less than or equal to 0, f of x value is minus x. So we will have 1 minus x into e power iu x dx. Similarly, when x is greater than or equal to 0, that is values will be lying between 0 to 1. So mod x will be plus x. So we will have 1 minus x into e power iu x dx. Okay, now evaluate this integral. What do we get when we evaluate this integral? You have over here minus 1 to 0, 1 plus x into e power iu x dx plus integral 0 to 1, 1 minus x into e power iu x dx. So let's apply Bernoulli's rule in order to find the integration of this term. So what is the integral of this term? First term into integration of second minus differentiation of first and integration of second, that is using Bernoulli's rule. So the first term is 1 plus x, integration of e power iu x, it's e power iu x divided by iu minus differentiation of 1 plus x, which is 1. Now integrate this term. So we will get e power iu x divided by iu whole square, because 1 iu was there previous as well. Next we cannot continue because differentiation of 1 will be 0 and the limits vary from minus 1 to 0. Now the second one. Take this as the first term and this as the second term. First term is 1 minus x. Second term is e power iu x divided by iu, then minus, differentiate this, differentiation of 1 minus x is minus 1, integrate that term again, e power iu x divided by iu whole square, and the limit vary from 0 to 1. I hope this is clear. Anybody has any doubt in this step? Okay, let's move on then. Let's substitute the limits. What do we get when we substitute the limits? Say limit is 0, upper limit is 0. So what happens when you put the upper limit as 0? Here we get it as 1 plus 0, which is 1, e power 0 is 1. So we will get 1 divided by iu when I put the upper limit. When I put the upper limit, it is plus 1. Then next put the lower limit, that is minus 1. So when you put minus 1 over here, this entire term will become 0. Okay, entire term will become 0. So what do we get over here? So the lower limit, when I put minus 1, it is going to be 0. So it will be 0, lower limit. Now come over here. It is, see here, iu whole square. That means I square u square. So I square is minus 1. So minus of minus will become plus, 1 by u square will remain. E power iu x. So e power iu x. When you put x as 0, it is 1. When you put lower limit, that is minus 1. What do we get here? It will be minus e power minus iu, because x is minus 1. You have to put x as minus 1. Upper limit is 0, so you will get 1. Minus lower limit is minus 1, so you will get e power minus iu. So this is regarding the first term. Now take the second term. Upper limit is 1. So when you put upper limit 1 over here, this term is going to be 0. So upper limit is 0 minus. You put the lower limit. Lower limit, sorry, this term also we need to put the, so we are substituting separately. So when I put upper limit as 1, so it will be 0. To this term only put lower limit, that is 0. So what happens here? it will be e power 0. 1 into e power 0. So 1 divided by iu it will be. 1 divided by iu. This is the first term. Now minus of minus will be plus, but here you have I square u square. I square is minus 1. So 3 times minus, you will have minus term only. 1 by u square. Now for e power iux, put the limits. So it will be e power iu, and when you put the lower limit, e power 0, which will be equal to 1. This is what we get after substituting the limit. Now check what we get over here. See 1 by iu and minus 1 by iu get cancels. Then you have 1 by u square. 1 by u square you have 1 by u square. Then minus of minus plus. So 2 times 1 by u square, that is 2 by u square. 1 by u square here, minus of minus plus 1 by u square. So it is 2 by u square. Now write what is remaining. Here it is. 1 by u square into e power minus iu and minus 1 by u square into e power minus iu. So if I take the minus sign outside, that is 1 by u square. What will remain? E power iu plus e power minus iu. Here it is, e power minus iu and e power iu. Minus 1 by u square I have taken outside. So that is equal to 2 by u square minus 1 by u square into, what is this? In yesterday's class I have proved this. E power iu plus e power minus iu is same as 2. Am I correct? Yesterday's class I have given the definition of it. E power iu plus e power minus iu is same as 1, 2 cos u. So now if I take 2 by u square outside common from both the terms, what do I get? 2 by u square is common, 1 minus cos u remains. So what is f of x? F of x is nothing but 2 by u square into 1 minus cos u. We know 1 minus cos theta is equal to 2 sin square theta by 2. So 1 minus cos u will be 2 sin square u by 2. Is it okay everyone? 1 minus cos theta is 2 sin square theta by 2. That's why 1 minus cos u is 2 sin square u by 2. This is so far. What is the final answer of Fourier series expansion? 2 2s are 4. 4 by u square into sin square u by 2. 4 by u square into sin square u by 2. So this is what? This is the Fourier transform of the given function. And they have asked us to deduce this expression to an expression of the form, here it is. And we need to find the value of this integrand. So according to that, what we have obtained, whatever value or whatever expression by Fourier transform we have got. So this is the Fourier transform. So let's use the inverse Fourier transform. We are using both of them in a single question. If they are asked us to find the value of certain integral, then only, or else you can stop till here. So from inverse Fourier transform, what is the definition of inverse Fourier transform? Inverse Fourier transform formula is given by f of x is equal to 1 by 2 pi integral minus infinity to plus infinity f of u e power minus iu x into du. Remember this is, always remember this is du. Do not write it as dx. I might have written somewhere by mistake, but please correct it. F of x is minus infinity to plus infinity f of u e power minus iu x into du. Now let's substitute all the values. So what do we get over here? F of x is equal to 1 by 2 pi integral minus infinity to plus infinity. You can write f of u. F of u is over here. So you will get 4 sin square u by 2 divided by u square into e power minus iu x dx. So that is equal to 1 by 2 pi into integral minus infinity to plus infinity. This 4 you can write it as 1 divided by 1 by 4. So it will become sin square u by 2 divided by u by 2 whole square. This 4 I have written it as 1 divided by 1 by 4. So it will become u square by 4 or u by 2 whole square. Is it okay everyone? Is it okay? Anybody, any doubt? Okay. Now what do we do after this step? What shall we do
Ma'am, e
after
power
this step? Yes, correct, correct. E power minus iux dx. So this is what f of x. Now in order to reduce that to that expression, here is the expression integration 0 to infinity sine square t by t square dt equal to pi by 2. We have to reduce the expression to this form. So in order to reduce that, what we do is we put x equal to 0. And we know f of x is what? 1 minus mod x. So when we put x equal to 0, what is the value of f of s? F of 0, it is 1 minus 0, which is nothing but 1. So let's substitute x equal to 0 in this expression star. So when we put in the expression star x equal to 0, what do we get? We get f of 0, which is equal to 1. That is equal to 1 by 2 by integration minus infinity to plus infinity sine square u by 2 divided by u by 2 whole square and e power 0, which will be equal to 1 into du. So this is what we get after we put x equal to 0. After this step, what we do is we make the substitution. Take u by 2 equal to t. Here is u by 2. So let's take that as t. So if I put it as t, what will be the value of differentiation of u? U will be 2 times t. Differentiation of u with respect to t will be 2t. Am I correct? 2 dt. 2 dt. So u will be 2 times. U will be 2 times t. Du will be 2 times dt. So this is what we get after substitution. Now let's put all these things. Also the limits you need to check. When this one u is minus infinity, t is also minus infinity. When u is plus infinity, t is also minus infinity. That's why limits remain the same thing. Rest all let's substitute. So what do we get? 1 divided by 2 pi integral minus infinity to plus infinity. U by 2 I have taken it as t, so it will be sine square t divided by t square into du is what? Du is 2 times dt. Is 2 times dt. So here 2 get cancelled. So what do we get over here? 1 by pi integral minus infinity to plus infinity sine square t by t square into dt. But this is not what we have to do. We have sine square t by dt equal to pi by 2. This is what we need to we check whether sine square t by t square is either even or odd. For that, what we need to do? We need to replace t by minus t. So what do we get when we replace t by minus t? It is sine square minus t divided by minus t whole square. So what do we get from this? What do we get? Tell me. What do we get from this when you replace t by minus t?
ma'am, sine square t by t square only, ma'am.
Yes, we will get it as sine square t by t square only. Therefore, the given function is even. Given function is even. If the function is even, you can write this as integral minus infinity to plus infinity can be written as 2 times 0 to infinity sine square t by t square into dt. So, from this expression, what do we get? 0 to infinity sine square t by t square into dt, that is equal to what we get? We get it as equal to pi by 2. Here it is 2 by pi, take it to the other side, it will become pi by 2. So this is the value of that integrand. Anybody wants to ask anything? Anybody wants to ask anything? No? Is it clear, everyone?
Yes.
Okay. Let's discuss the next question. Find the Fourier sine and cosine transforms of. Need to find the Fourier. Now let's discuss about Fourier sine and cosine transforms. Fourier sine and cosine transforms. So first they have asked us to find the Fourier sine and cosine transform of the function f of x is equal to e power minus alpha x, where alpha is greater than 0. So we need to find the Fourier sine and Fourier cosine transform of this function. First write down the formula for Fourier sine transform fs of u, that is equal to integral 0 to infinity f of x into sine ux dx. Similarly, FC stands for Fourier cosine transform. It's given by integral 0 to infinity f of x cos ux dx. Okay, so now let's substitute that fs of u, that is equal to integral 0 to infinity f of x is over here, e power minus alpha x, e power minus alpha x into sine ux dx. Now I hope you all remember we had discussed two formulas, e power ax into sine bx dx, that is equal to what? Anybody remember these two formulae? Anybody
Ma'am,
remember?
e power ax
Yes.
by a square plus
Then
sine bx plus cos bx.
very good. A sin bx, but it is negative over here, not positive. A sin bx minus b cos bx. So this is the formula, and then we have to put the limits. Next one more was power ax into cos bx dx. That is e power ax divided by a square plus b square into a cos bx plus b sin bx. So these are the two formulae we have discussed. So let's expand this one using this formula. What do we get? According to that, what is the value of alpha? Write it. Compare these two. Compare these two. What will be A? A will be minus alpha. What is B? B is U over here. Remember this. B. Okay, B is U and A is what? Minus alpha. So when you put that in the formula, what do we get? Fs of U as Fs of U is equal to e power ax. So e power minus alpha x divided by minus alpha whole square plus B will be U square into A minus alpha sine ux minus B is U, B cos Bx. Is it okay, everyone?
Yes.
Okay. And what about we have the limits as well over here, 0 to infinity. Limits vary from 0 to infinity. So when you put the limits, what we get? Just see over here, you can solve it easily. The upper limit is infinity. Here you have e power minus alpha x. So when you substitute, it will be e power minus infinity. E power minus infinity is 1 by e power infinity, which is nothing but 1 by infinity, which approaches to 0 as e power infinity approaches to infinity. So this is what.
Ma'am,
So when yes,
ma'am,
what
e
happened?
power minus nothing. It's okay. Clear
Oh,
now.
oh. So upper limit will be 0. 0 minus, put the lower limit. Lower limit is 0, e power 0 will be 1. So 1 divided by what we will have? 1 by alpha square plus u square. When you put x as 0, this will be 0. When you put x as 0, cos 0 will be 1. So u into 1. And you have a negative sign over here. So it will be minus u. So this is what you get. Minus of minus will be plus. So we have u by alpha square plus u square as our Fourier sine transform. Anybody has any doubt? Within 2 steps you get it if you apply this formula. Anybody has any doubt? This formula I have been explaining since day one. We have learned this in Laplace transforms as well. Anybody has any doubt? Check this once again. No?
No, ma'am.
Okay. Next, after we find Fourier sine transform, now let's find Fourier cosine transform. What is Fourier cosine transform formula? 0 to infinity f of x cos ux dx. So that is equal to 0 to infinity f of x is e power minus alpha x, e power minus alpha x into cos ux dx. Cos ux dx. Now apply the second formula, e power ax into cos bx, this formula. It's e power ax by a square plus b square. So here also a and b are same. A is minus alpha, b is u. So according to that, it's e power minus alpha x divided by a square. A is minus alpha whole square plus b is u square into minus alpha cos ux plus u sin ux. This is after applying this formula. See this formula. A is replaced by minus alpha, B is replaced by u. Is it okay everyone? Just check the formula everyone. You must be thorough with the formula by now. Done? If anyone doesn't know, please write down this formula. Very important. Okay. Afterwards, we'll continue over here. Fourier cosine transform. We have substituted after making use of the formula. Now let's substitute the limits. Limits vary from 0 to infinity. So what do we get? Again 0 to infinity. Upper limit is infinity. So we will have 0. Upper limit is infinity. So e power minus infinity same as 1 by e power infinity, which is 1 by infinity, which is 0. So upper limit is 0. Now put the lower limit, which is 0. E power will be 1. So 1 cos 0 into minus alpha. So you will have minus alpha and sin 0 will be 0 divided by what we will have, alpha square plus u square. So this is nothing but alpha divided by alpha square plus u square. So what is the Fourier cosine transform? Square plus u square. What is the Fourier cosine transform? It's u divided by alpha square plus u square. I hope this is clear everyone. Anybody has any doubt in this formula problem?
No, ma'am.
Okay. Please ask me if you have any doubt. Do not keep your doubts pending. Okay. Okay, if this is okay, we will move on to the next question. Obtain the Fourier cosine transform. Obtain the Fourier cosine transform of the function f of x is equal to 4x when x lies between 0 and 1, 4 minus x when x lies between 1 and 4. Then we have 0 for x greater than 4. This is how the function is defined, and we need to find the Fourier cosine transform of this. We need to find the Fourier cosine transform of this. What is the formula? Cosine transform fc of u, it is 0 to infinity f of x into cos ux dx. So that is equal to integration 0 to infinity f of x. What is f of x? Is 0 to infinity is there. So you need to split into 3 parts now. See, when x lies between 0 to 1, x lies between 1 to 4, and x lies between x is greater than 4. We can leave out this last term because when for all the values of x greater than 4, function value is 0. So you can leave out that term for only the first 2 terms. 0 to infinity, let's split it as 0 to 1. Split it as 0 to 1. When it is x lies between 0 to 1, f of x is 4x. So we will get 4x into cos ux dx plus next one, x lies between 1 to 4. 1 to 4, f of x is 4 minus x cos ux dx. Then when x lies between 4 to infinity, for all the values of x greater than 4, that means 4 to infinity, f of x is 0 cos ux dx. So this is the formula, and this is how I have split 0 to infinity into 3 parts: 0 to 1, 1 to 4 and 4 to infinity. However, this term is going to be 0 over here. Let's evaluate the first two integrand. So what we get when we evaluate these? We have to use the product rule of Bernoulli's. So let's apply that. First term, keep it as it is, integrate the second term. That is sine ux divided by u. Okay, then negative sign. Differentiate 4x. Differentiation of 4x is 4. Integrate sine ux by u. So it will be minus cos ux by u, and u into u will be u square. Limits vary from 0 to 1. Next, consider the second one. First term, second term. First term is 4 minus x. Second term is what? Integration of cos. It is sine ux divided by u minus. Differentiation of 4 minus x is minus 1. Integrate this, we get minus cos ux by u into u. It is u square, and the limits vary from 1 to 4. Is it okay, everyone? Is it okay?
Yes, ma'am.
Yes.
Let's put the limits now. What happens when we put the limits here? 4 by u I can take common. If I take common outside, what will remain? X sine u will remain. Here x sine u will remain. X is 1, so sine will be sine 1. X is 1, so it will be 1 into sine u, because x is 1. So you will have 1 into sine u. When you put the lower limit, sine 0 is 0, so you will have it as 0. Over here, minus of minus will be plus 4 by u square into cos u. X is 1, so you will have cos u minus. When you put cos 0 value is 1. Plus here, when you put x as 4, what happens here? I can take 1 by u outside. If I take 1 by u outside, upper limit is 4. So when you put 4, it will become 0. Then put the lower limit 1 minus x. If you put it as 1, 4 minus 1 is 3. Correct? So you will have sine u divided by u. Am I correct? Am I correct? Is it correct? Yes? This 1 by u I have taken outside. Put the upper limit 4. When you put it as 4, it is 0. Now put the limit 1. So it will 4 minus 1 is 3. 3 sine u it will be. Next. Here what happens? Minus minus minus. It will be minus 1 by u square into cos 4u. X is 4 minus cos 1. Cos 1. That is cos u. Okay? Anybody, any doubt? Let's simplify this. What do we get over here? 4 by u sine u. Then here we have 4 by u square into cos u. Then 4 by u square into minus 1 is minus 4 by u square. Then here what we have? Minus 3 by u into sine u. Last term, minus 1 by u square into cos 4u. Minus of minus will be plus 1 by u square into cos u. Now try whether you can cancel out any term in order to write 4 by u sine u. See here, 4 by u sine u minus 3 by u sine u. 4 minus 3. 4 minus 3 is 1. So you will have 1 by u sine u. Whereas 4 by u square cos u plus 1 by u square cos u. Am I correct? Is it? 4 by u square cos u plus 1 by u square cos u will be 5 by u square into cos u. Then what else is remaining? Here you have minus 4 by u square. Then this term already considered. What else is remaining? Minus 1 by u square into cos 4u. Is it okay? Check everybody. Is it okay?
Yes, ma'am.
Yes. Okay. So this is the Fourier cosine transform of the given Fourier transform or the real valued function which is given to us. There will be given a real valued function f of x which is defined in certain intervals, and we are finding the Fourier transform of that real valued function. Is it okay?
Yes, ma'am.
Anybody has any doubt or anybody wants to ask anything?
No,
Please
ma'am.
ask if you want to ask anything, anybody, and please refer to my notes. Okay, and learn thoroughly whatever we have discussed in today's class. Okay, remember that. So we have here Fourier sine and cosine. Same in order to evaluate the value of the integral. Whenever you have to evaluate the value of the given integral, you have to use the inverse of it, inverse transform of it. Then we will obtain the value of the integral. Okay. Today's class is clear to everyone. If you have any doubt, please contact me. Okay. Let's meet in next class. Thank you, everybody.
Thank you.